Hi, I'm Dr. Craig Steingraber here at the Summit Healthplex in Noonan, and welcome to Naturally Healthy. Thanks for joining me again, and this week we're going to talk some more about the human nervous system. Last week we talked about different types of receptors that allow us to feel certain things, sense certain things, and I want to briefly go over that aspect of the show in about a minute or so. But the primary goal here for last week's show, this week's show, and a couple more weeks from now is to give you a map of our human nervous system so that you can better understand how we feel things, whether it be good or bad, and how we do things, whether it be good or bad. And much of that is done through this map that I'm going to give you, and how these different nerves and receptors are stimulated and how those nerves stimulate us. So, if you have a better understanding of this map of how the nervous system's put together, I think you're going to have a better understanding of how you feel things, why you do things, and quite possibly how you can have access to different types of clinicians to give you advice on how to improve that aspect of our function or our nervous system. Because I've said before, the nervous system controls everything. And if it's irritated or not functioning in a proper way, we're going to have problems. Now, let's rehash last week's show. There are generally 5 different senses, and those senses act based on a receptor being stimulated by something. So number 1, sight, color, and light enters our eye, and a receptor in the back of our eye receives that stimulus, which then gets turned into electrical energy and sent into the brain to have a picture of something or to allow us to see something. That's one sense. A second sense is smell. We smell something, good or bad. A receptor on the inside of our nose receives that odor, we'll say, and it immediately gets it turned into electrical energy and gets taken into the brain to have a certain type of perception of a smell. 3, taste. We put something on our tongue. It has a different taste. As soon as it hits our tongue, it turns into electrical energy and gets sent into our brain so that we experience that taste. 4, I think we're at 4, sound. We have some kind of sound that comes into our ear. It gets received by a receptor. It turns into electrical energy. It goes into our brain, so we perceive that sound. 5, touch. We have someone touch us anywhere. There's receptors immediately in the skin or even in the hair cell, or where our hair joins our skin. And there's different ones there for touch and hair cells. We receive that touch. A receptor receives it. It gets sent up eventually into the brain so that we perceive that sense of touch. Now, those are essentially the 5 basic senses all of us were taught in grade school, for that matter. But it's really not as complete as it should be. There are other senses or receptors in us that are extremely important as well. One is for balance. There are different nerves and muscles and joints and ligaments and other types of tissues in our body, different nerves in our inner ear that have a lot to do with receiving information, turning it into electrical energy, and creating an integration into our brain that gives us certain aspects of balance. Another one for joint position sense, knowing if I close my eyes and move my finger up, I know that it's up because I can sense that it's up. I know that it's down because I can sense that it's down. I'm not looking at it, but I know it's in those positions because of certain nerves in the muscles, in the joints, in the ligaments, etc., in and around that finger that tell my brain what position that it's in. Now, there's also nerves, as we talked about last week, for temperature, hot, cold, warm, cool, different nerves, different receptors in different parts of our body that end up telling our brain which type of temperature that is. Now, of course, last but not least, there's a sensation that is pain. And some people are more sensitive to pain than others for many different reasons that we're going to have a few different weeks of shows that is going to be specifically on pain and how it is, in the many ways it's generated and controlled. But certainly there are peripheral types of nerves. Nerves, well, they don't necessarily have to be in the periphery, but nerves in our body that transmit only pain and different kinds of pain. Aching pain, burning pain. That's why when you go to a clinician, they'll ask you, well, is it burning? Is it numbness? Is it tingling? Is it ache? Is it deep? Those mean different things based on different activations of nerve, pain, those types of pain nerves, and it gets sent into the brain for us to experience that sensation. So there's a brief overview of the basic different receptors in our body that receive a stimulus and turn it into electrical energy and send it into our brain where we have a perception. Now, let's move into this map of our nervous system. This is extremely basic, and I've showed this to you guys many times before, but it's an extremely basic map of what we call our peripheral nerves. Not all, most of them, of the basic aspect of it. And as you can see here, my point with this poster here today is this. These yellow things that come out at different levels of our spine, you see them distribute into different areas of our body. Mid to lower neck, down to our arms and hands, lower back, around our hip areas here, actually down into our legs. And then, of course, we have the aspects of our main thorax, or main part of our body. Now, here's what I want you to understand, this basic tenet here. We have receptors, right, that receive a stimulus, no matter what it is. It gets turned into electrical energy, and that transmission of that energy or that electricity or nerve signals is transmitted towards our spinal cord, which we're going to talk about next week, and then up into our brain, which we'll talk about a couple of weeks after that. So the point is, we have a stimulus, it gets sent up a nerve, the electrical energy or signals get up a nerve into the spinal cord. It goes one way. Now, after the spinal cord and or the brain processes that stimulus, it sends directive information back out the same general aspect of the nerve here by the spine. Then it branches off and goes to different areas. Now, it may go to organs. It certainly may go to muscles. Okay? So, stimulus from the outside gets carried towards our spinal cord and up to our brain. Brain processes it. Spinal cord may process it. Send nerve signals out or away from the spinal cord and brain. That, in many senses of the word, is called a motor response. Sensory in, motor out. That's basically how it works. Now, based on the level of those exiting and entering nerves, the level of our spine, those nerves supply or cover or control different areas of our body. That's why, one of the reasons why our spine, the actual structure of our spine, is so important to keep healthier. Because if you're misaligned, if you're stiff or tight and your muscles or joints and your ligaments are too stiff, if there's a lack of proper mobility, as I mentioned, is aspects of spinal misalignment. It doesn't have to be scoliosis. It can be minor misalignments. It can disrupt the messages into our spinal cord and then ultimately up to our brain. It can disrupt messages coming down from our brain and out from our spinal cord. Hugely, hugely important component of our health. We'll get to that in another time. But that's the map here. So now what I want to do is I want to show you a scan here. You'll see this on your screen of a sensory aspect receiving stimulus of our body. Now once again, there are different components of the spine and the nerves that exit and enter at that spine that supply different things in our body, organs, muscles, skin, whatever. Now, looking at this scan, if you look at to the left side there, it'd be the example as he's looking forward, it'd be on his right side. On the upper part of the outside of his shoulder, you can see a letter and a number, C5. Now, C5 means cervical and fifth level. So let's just count this out. 1, 2, 3, 4, 5. This is the C5 level, the fifth cervical level. Now right above that bone, really if I turn this, the actual nerve comes out this way. And on the other side, let's move over to here. I'll just give you an example. 1, 2, 3, 4, 5. Right up here, this nerve comes out and eventually it comes down and branches off and supplies the sensory perception of that aspect of our shoulder, kind of out into this direction, shoulder and arm. All right? It also, there is some overlap. I don't want to get this technical, but I'll just throw it because I've gone there. There is some overlap in the neck, in the nerves that come out of and enter the neck. There's a lot of overlap of different spinal levels in the arm. Not so much hardly in the leg, which we'll get to here in a second. But that's the principle that I wanted to relate here. Let's take another one. If we go to, stay on the same arm there on the right side of this gentleman. There you may say T or CT1. Now, T1. This is C1, C2, 3, 4, 5, 6, 7. Now it starts to change names into what's called the thoracic spine. This is the first thoracic vertebra. There's 12 of them. All right? Now, as you see, let's go down here. 1, 2, 3, 4, 5, 6, 7, T1. There's nerves that exit out from that side and on the other side. And there's hundreds of thousands of branches of just this one nerve root here that comes down and eventually branches off and supplies the inner part of our arm here. So anything we feel right there, that sends what? It stimulates a receptor which receives this stimulus of touch, and it sends turns it into electricity, sends it up to and into this area right here of our spine, that level of our spine. Now where else? Right there. So, at any distribution of that and those nerves, whether it's at the spine or any distribution down, well actually I should go back, we're getting to the down part here in a second, I'm a little ahead of myself. Any distribution from here on up to this level and any dysfunction, whether it's tightness, stiffness, disc problems, whatever, at this level you could have some type of feeling along any of that distribution. Now, let's look at this scan again. And let's go down to his legs, figure on the right. Let's look at this individual's left leg on the inside where it says L4.